integrate integral of x squared minus 3x minus 3 over x minus 1 quantity square times quantity x squared plus 2x plus 2 with respect to x. Okay, now we want to write this fraction as a sum of simpler fractions. So we have x minus 1 is squared, so we need to write two fractions for this factor. So x minus 1, a constant over x minus 1 plus constant over x minus 1 is squared, plus this does not factor, so x squared plus 2x plus 2 here. This is a degree 2 polynomial, so we need to go for degree 1 on the top, so cx plus d. Okay, now we are saying this fraction is equal to sum of these three simpler fractions. So we combine these three fractions on the right side, take the common denominator. The common denominator will be same thing like the left hand side. Okay, so the top x squared minus 3x minus 3 is equal to a times what is missing here from this common denominator. X minus 1 is there, so x minus 1 is squared, so one copy of x minus 1 and x squared plus 2x plus 2, plus b, what is missing here from this common denominator, just x squared plus 2x plus 2, that's over here, plus cx plus d, and what is missing here from this common denominator, just x minus 1 is squared. And by the way, x minus 1 is squared is same as x minus 1 times x minus 1, which is x squared minus 2x plus 1, if you fill this out. Now from this expression we need to find the values of a, b, c and d. Okay, this is the identity in our case. We are just saying left hand side is equal to right hand side, and if we look at the right hand side, we have x minus 1 which is 0, taking x equals 1. So we take x equals 1 first, that's the easy part. Plug in 1 here, 1 is squared minus 3 times 1 minus 3, minus 3 minus 3 minus 6, 1 minus 5, negative 5, 1 minus 1 0, so the whole term is 0, plus 1 is squared plus 2 5b, and x minus 1 0 is squared, that's 0. So negative 5 equals 5b, so b equals negative 1. So out of 4, b is known now, b is negative 1. Now there is no factor that becomes 0 taking x value, because we have x minus 1, this is always positive, not necessarily, but x squared plus 2, it does not factor, so we cannot find a number, nice number like 1 2 3 or negative 1 negative 2 negative 3 that make this 0, so not the case. Then what we do, since we said the left hand side is equal to right hand side, and if you look at the right hand side and multiply out x times x squared x cubed, there is no x cubed here, but cx and x squared cx cubed, so we can equate the coefficients from both sides. There is no x cubed in the left hand side, that means 0 x cubed. So we want to equate the coefficients. First we want to take the coefficients of x cubed, and there is no x cubed term, so 0, the coefficient is 0, or you can always add plus 0 x cubed. In the right side, where if we multiply this out, x cubed, x squared x cubed, ax cubed, so a is there, that's the only x cubed term. There is no x cubed term here, and if we multiply out, x minus 1 squared is in fact x squared minus 2x plus 1, cx x squared cx cubed, and the coefficient of x cubed would be c. So left hand side nothing, so 0 equals a plus c. From this we can solve for a, just move c to the other side, subtract c, so a equals negative c. Okay, now what we found here is, as soon as we know the value of c, we can find the value of a. And let's go for more here. Let's equate the constant terms. Okay, that's next easy term, I think. So constant term in the left hand side is negative 3. Negative 3 is equal to, if we multiply out negative 1 last, negative 2, negative 1 times 2, negative 2, that will be the constant term, negative 2 and a outside, negative 2a. If we multiply out b times 2, 2b, that will be the constant term. And if we multiply out d times 1 d, that will be the constant term, which is same as negative 3 equals, now a is negative c, so negative 2 times negative c, just positive 2c here. 2b, b is already found to be negative 1, 2 times negative 1, negative 2, and d is just d. Now we can solve for d. D equals, bring these two terms, bring this to the left side, then negative 3, this plus 2, negative 1, and 2c becomes negative 2c. So that's d. Again, d is given in terms of c. A is also given in terms of c. Okay. Next, let's equate the coefficients of, we can go for x square or we can go for x, it doesn't matter. Let's go and equate coefficients of x. X means negative 3 equals, if we multiply out x times 2, that's 2x, that will have x term, and negative 1 times 2x, 2x, negative 2x, x times plus 2, 2x, they would cancel. That means there are no x terms. So no x terms from the first. Let's go for the second. If we distribute b, 2bx, so 2b, that's coming from the second here. Here if we multiply out here and here, cx and 1, that's cx. So coefficient of x is c. And if we multiply out d and 2x, I mean we have to multiply everything, but d times negative 2x, negative 2 dx, that will have x term, so negative 2d, so negative 2d. Now we write down the value of b. B is negative 1, so 2 times negative 1, negative 2. Okay, let me erase this. And we get negative 3 equals 2 times negative 1, negative 2 plus c, and d is found here, negative 1 minus 2c. Let's distribute negative 2. Negative 2 times negative 1, positive 2. Negative 2 times negative 2c plus 4c. From here, negative 2 and positive 2 cancel. C plus 4c, 5c. Negative 3 equals 5c. Now divide by 5. Then we get c equals negative 3/5. So we found the value of c. Now plug this back here, we get d. Then d is equal to negative 1 minus 2 times c. C is negative 3/5, which is negative 1, negative times negative positive, 2 times 3, 6/5. 1 is 5/5 plus 6/5. 6/5 minus 5/5, so 1/5. That's d. And now let's plug in c. Here we get a, and a equals negative c, so negative of negative 3/5, just positive 3/5. So thus we found the values. Here's b first, here's a, b, here's c, and here's d. D equals 1/5. Okay, that's d. Now we go back and plug these numbers into this equation here, then we can integrate. Now the integral becomes, because we found the values of a, b, c, and d, integral of a over x minus 1, so a is 3/5 over x minus 1, plus b over x minus 1 is squared. Okay, so second here, that's negative 1 over x minus 1 is squared, plus cx plus d, negative 3/5 x plus 1/5 over x squared plus 2x plus 2 dx. Okay, now we evaluate the integral here. The first one is easy because 3/5 can be pulled outside. Then we have 1 over x minus 1. The derivative of x minus 1 is 1, so the entire derivative of 1 over x minus 1 is natural log of x minus 1, plus minus 1 can be pulled outside, minus 1. Now we have 1 over x minus 1 is squared. Let's move this to the top. This is x minus 1 to the negative 2 dx. In next step we can use power rule. It's like u square, u to the negative 2 du. Okay, now here negative 3/5, at least 1/5, negative 3/5. To find this integral there are several ways possible. So let's factor negative 3/5 outside. Okay, if we factor negative 3/5 outside, the bottom is x squared plus 2x plus 2 dx. Then what is left here? X. Since we factor negative out, then we have to have negative, because negative times negative will be positive. 1/5. 1/5 is out. Also we took 3 out, so when we multiply, when we distribute, we have to get back 1/5. So 5 is out, but 3 goes on the top. To cancel, this is 3, 1/3. Okay, you can check. Negative 3/5 times x, negative 3/5 x. Negative times negative, positive. 3/5 times 1/3. 3 and 3 cancel, 1/5. Okay, and we'll take care. I mean, this takes some time. And here is 3/5 natural log of x minus 1, and that's negative 1. This is like u to the negative 2 using power rule. X minus 1, negative 2 plus 1, negative 1 divided by same thing, negative 1, and this is negative 3/5. Okay, we have x minus 1/3 over x squared plus 2x plus 2. So we need to do a little bit of work here, and on the bottom we have x squared plus 2x plus 2. As I can see, the derivative of bottom is 2x plus 2, and we have x, but we can always multiply by 2, so we can make 2x plus 2 on the top. Let's do that. Okay, so here is x, so we need to multiply by 2. We can multiply by 2, at the same time divide by 2. We could have written outside 2 to cancel, just x. In fact, there are 2 terms, so this is 1/2 for everything, so we need to put parentheses around 2x. By the way, the derivative of bottom is 2x plus 2. We are trying to get 2x plus 2 over there, so 2x plus 2, let's put 1 when we distribute 2x plus 2. This plus 1 is not here, so subtract 1 to cancel this one, and negative 1/3 is on the top. Okay, so this is good, and negative and negative, this will be positive, and negative power means 1 over x minus 1. Okay, minus 1/2, bring to the outside, 3/5, 1/2, 3/10, and we have this integral. And this, now we need to distribute. Let's combine these two. We need 2x plus 1 minus 1 minus 4 1/3. X plus 1 is needed because when we distribute 2x plus 2, that's the derivative of bottom. Negative 1 minus 1/3. I want to combine these two. Negative 1 minus 1/3 is negative 4/3 here, over x squared plus 2x plus 2 dx. Okay, so let's simplify. Now distribute, put x plus 1 together, because when we distribute, that's 2x plus 2, that's the derivative of bottom. Okay, let me write this and I'll come back. We have 3/5 natural log of x minus 1 plus 1 over x minus 1, negative 3/10. Now we want to separate this top into two integrals, because when we distribute this 2, this is 2x plus 2, just leave that. 2x plus 2 is the derivative of bottom. So 2x plus 2 minus 2 times 4/3, that's 8/3 over this into second fraction. 2 times negative 4/3 is negative 8/3 over this dx. And this part is done because the top is derivative of bottom. So this will be same thing, minus 3/10. This is natural log of bottom, x squared plus 2x plus 2. Maybe we want absolute value here. Minus 8/3 can be pulled outside, that's the constant. 1 over this. This is irreducible, it doesn't factor, so we need to complete the square. X squared plus 2x plus 2 is like this: x squared plus 2x plus 2. That is in fact x squared plus 2x. We need to add half of 2 squared. Half of 2 is 1. 1 squared is 1. So we need to add 1 and subtract 1, and we have plus 2. X squared plus 2x plus 1. From these three terms we get x plus 1 quantity squared, and minus 1 plus 2 is plus 1. In fact, x squared plus 2x plus 2 can be written as x plus 1 quantity squared plus 1 and dx. Okay, last step, we find the antiderivative here and we are done. So let me copy this and I'll come back. So we have 3/5 natural log of x minus 1 plus 1 over x minus 1 minus 3 over 10 times quantity natural log of x squared plus 2x plus 2. The very last one now, negative 8 over 3. This is kind of, if we think x plus 1 is u, so 1 over u squared plus 1. It's just like 1 over x squared plus 1 dx. Derivative of x is dx. Same thing here. Derivative of x plus 1 is also 1 dx. So that's tangent inverse of x. So this will be tangent inverse of x plus 1. Final plus c outside. If you want to simplify, you can distribute negative 3 over 10 to these two terms, but this is it.